Good morning, everyone. I'm Sarah Seibert, Managing Editor with GovCIO Media and Research. And as Mike so kindly set up, we're going to be talking about the future of AI in government through a cybersecurity lens. So with me, we have Laura Freeman, the Deputy Director of Virginia Tech's National Security Institute, Cynthia Kaiser, Deputy Assistant Director for FBI Cyber, Paul Rodriguez, the Chief AI Officer at Microsoft's National Security Group, and Lieutenant Commander Ian Rossell, the Deputy Director of the Center for High Assurance Computing Systems at the U.S. Naval Research Laboratory. So thank you all for joining me today. So we often talk about AI in terms of its benefits, improving efficiency, boosting security, but at the same time, there are many risks that are associated with it. So this is a very timely discussion as bad actors, are leveraging AI to their advantage. And I'm looking forward to learning from you all who are responsible for the many facets of AI, from development, testing, and evaluation, deployment. So let's jump in. Cynthia, I'll start with you. So how can AI increase efficiency and accuracy in threat detection?
Well, I think we're so excited at the FBI for the ability for AI to really amp up cybersecurity across U.S. networks. Because, from the FBI and I'm cyber division, which is a little different than our chief information office, we look at it as threats. And I think from our perspective, we're always thinking about the bad guys. How are the bad guys attacking? What are they doing to us? The AI has this potential to really amp up the other side. Like, how do we stop our adversaries from getting onto our networks in the first place? How do we see them coming? And how do we enable our net defenders across the nation to be able to counter them before they ever get on their network, to find them before they ever know that they even got rebuffed. And I think that's where we're really seeing the efficiency aspect. It's not just about the ways in which AI can help us with our admin processes and all that, which is awesome, right? But how can we do things in this automated way that make us safer?
Right, that makes sense. So speaking of doing things in an automated way, using that technology to your advantage, Ian, how can AI and large language models be leveraged to enhance assurance of systems? And then how do high assurance systems facilitate a more resilient AI-enabled systems?
Great question. Tackling the first side of that equation, I think it's important to tie assurance to resiliency, which is a major effort these days. And assurance ties into resiliency under the NIST framework in terms of protection and withstand. It's important to emphasize it's not just operational resilience, which is focusing on the detection, mitigation, and adaptation part of resilience. And per the White House Office of Science and Technology Subcommittee I'm on for Resilience, Secure by Design is a major effort in that realm. In terms of resiliency measures, it's important that that's informed by the risk associated to that you're trying to mitigate, which should be tied to some notion of mission survivability. Whatever your mission in your organization is, you want to make sure you're not just gold-plating your operation, having multiple levels of redundancy, but at the same time, you want to be able to justify, hey, I need to have a redundant system here, and it might cost more, but there's an actual reason for it in terms of the mission. And lastly, I like this as a foot stomp. It should be informed by the threat exposure. So in a lot of cases, we might have a vulnerability, but if it's not exposed to the adversary, is it really a priority for you to mitigate? And so it shouldn't be just about, I have this version of this software in my system, but it should also be, is that vulnerability reachable and exploitable? In the Navy, we have a goal of reducing several classes of vulnerabilities up front, which is a lot of what the Secure by Design efforts are all about. And just a couple of quick samples. We're looking at one, I'll just say because in the interest of time, we're trying to reduce the hallucinations of large language models. One technique, counterexample guide, or refinement is a great approach to try to tie the results and outputs to a formally verified model so you can get some kind of oracle that can inform and sanitize the outputs. And we're doing that. We actually have one that we presented recently actually automatically generating patches for vulnerabilities. And so in the other direction, much of the threat vectors are the same in the other direction, which is assurance for AI. Which even if some of the vulnerabilities, exploits, and payloads are unique to AI specifically. I mean, so a lot of the same techniques will apply. Encryption protects data at rest and in transit. You want to sanitize inputs and prompts, and memory corruption and side channels continue to be threat vectors for exploitation. But one unique thing I would say to AI is interesting is homomorphic encryption, which is taking rise, which is how do you take the compute stack out of your root of trust? Because in theory, you could operate on encrypted data directly and maybe leverage more commodity resources in a less trustworthy environment.
Right, yeah, and Laura, as agencies are developing these systems, you play a role in the testing and evaluation of them. So what are some of the processes that you're using for mission assurance?
Yeah, so I've been in test and evaluation for my whole career, and I feel like test and evaluation is having its heyday right now because it's so important for assuring AI. And I like that we're talking about mission assurance and AI assurance because that builds on a legacy of assurance. Before AI assurance, we were talking info assurance, software assurance, quality assurance. All of those assurance capabilities came with a tool set that we are now building on for AI assurance and mission assurance. So one of the things I like to emphasize is that there is no one right way or one right tool set, but quality assurance reminds us that it's about the systematic processes that we use to gain those level of confidence in a capability. And so for AI assurance, we're building on all those systematic processes. And I particularly have worked for supporting the Director of Operational Tests, DoD, test and evaluation. We have a very rigorous test and evaluation process that we use because we have to make sure that we are assuring the mission capabilities that we are delivering to the warfighter. And so none of that goes away. Systematic test design, being able to evaluate human system interaction, leveraging modeling and simulation, how we verify and validate and understand the uncertainties associated with that. That all still is the building blocks of what we're looking at for AI assurance. That being said, there are some new failure modes Ian mentioned hallucinations of large language models. We know that we can have failures that occur from unexpected outcomes. We don't know what factors necessarily are driving failures in AI-enabled systems. And so those systematic test and evaluation processes become more important in that we're doing a test design, we're understanding how a capability works across its operational envelope, and then we're learning where it fails throughout the process. So that's a really important part of this. And in some of the work that we've done at the National Security Institute, we've gone through some of the computer vision models and systematically learned what types of capabilities can cause failures and then build those into our next test set. So I think that learning process is key. Another piece very relevant to this group is the cybersecurity and the attack surface that AI brings. And so we have a robust history of doing cyber testing on our systems that we're building on. But that didn't necessarily account for things like data poisoning and model inversion. And so building up new systematic methods for how we deal with that increased attack surface is an important part. And really, it's not rocket science. It's about the scientific method and documenting what test cases and when you find failures and doing root cause analysis. But it becomes that much more important when you're talking about an AI-enabled system.
Right, not rocket science, but computer science.
Yeah, data science, computer science together.
Science, that's a good one. Yeah. So, Paul, how is your organization supporting implementation of AI systems after, as Laura was talking about, the evaluation process?
Yeah. So when you're talking about artificial intelligence, the field goes back decades. But we're currently going through a boom that has released millions of models, right? And those models have different trade-offs in the performance for a particular task, the cost to use them, and the latency to execute the task. And as we're developing applications, new models are coming out all the time. I came in this morning and immediately checked the news to make sure I didn't miss anything this morning before coming up on stage. And so Microsoft views the future of AI integration into applications as a very multi-model future. So while there are millions of models out there, Azure supports over 2,000. Of course, there's initial evaluation of those models for security. But the models are coming out continually. New versions of the same models will come out. And those may allow for efficiency or latency improvements, reduction of cost. And we're going to want to integrate them. And that requires a continual risk assessment on the models. These models themselves, when we're talking about generative AI application, we have a foundation model which is wrapped in guardrails, which is wrapped in meta prompting, which is wrapped in application. And if you change and many of those layers are non-deterministic, and have very complex interactions between them. Modification of any layer requires retesting of every other layer. So I think that it's not just an initial assessment that's required, but a continual and constant assessment.
Right, that makes a lot of sense. And we alluded to this earlier, but as we are using AI to leverage its benefits, there's also adversaries that are leveraging it to improve their own attacks. So Cynthia, as AI becomes commonplace, how are adversaries leveraging this tech to their advantage?
You know, AI is really changing how everybody probably is experiencing cyber threats. And I think pretty much any adversary you're thinking about, gosh, I hope they're not using AI. Yeah, they're using AI. But it's really not to the level at which I think people were scared when some of these, new Gen AI models were coming out. The LLMs right now really don't allow for game-changing cyber threats to be occurring, but it's still helping our adversaries out. And to be clear, when I say our adversaries, I mean cyber criminals as well as China, Russia, Iran, North Korea. It's really helping them in 3 ways. 1, labor saving. It helps them with basic admin tasks like we all do, developing a PowerPoint on an exploit so that you can help your colleagues out in your hacking adventures, checking code, doing some really basic scripting tasks, all these kind of little elements out there that add up to efficiency gains across an adversary's program. Second, it makes their lies more believable. And this is true in terms of the massive amount of additional phishing your organizations have probably seen, as well as the sophistication of particular spear phishing messages, not having to necessarily rely on looking at an email and thinking, gosh, a non-native English speaker really wrote this, as well as deepfakes. I think the most poignant deepfakes and the ones that to me are the scariest are where we hear about a deepfake of a company's CEO and they're sitting at their vacation house that you've seen them at how many times before, and they call their financial team and tell them to transfer money. How many of us would fall for that? I would. And so, I think that that's like this area of AI that to me is probably the most concerning, like from a corporate standpoint of really thinking about like, what are those checks there for us to do? And then third, it helps them hide what they're doing better. So being able to get onto a network and then use AI to map a network, to understand a network better, to move laterally across the network. So, you take all of that together and what you really see are adversary programs that are better than maybe they were a few years ago. I think it really helps some beginner hackers get to intermediate. And, we're obviously monitoring this incredibly closely so that we know where adversaries might go, what they might do next, but also what they're not doing now, so that we can help inform out for all of you that there's not this massive weight towards adversary AI programs. Like, we really continue to think the benefits of AI on the cybersecurity side far outweigh what our adversaries are being able to do.
Yeah, that makes sense. And Ian, Cynthia talked about that corporate risk in the landscape from the defense lens. What are you seeing? Are there similar risks, or are they different?
I was going to say kind of somewhat of a similar vein about automation is what is key. Adversaries are able to probe our defenses quicker, and in some ways they can develop exploits faster as a result as well. And just to say, on the defender side, we need to be using the same technology to our advantage, and that's key. So it's funny you mentioned network mapping. When I was at the Joint Artificial Intelligence Center helping to stand that up for the DoD, I ran the autonomous network mapping program. And my foot stomp there always was, hey, we own this key cyber terrain. Our true advantage here is our ability to know our own terrain, because we're holding that key terrain right now. And so I think that's the true advantage if you were to pit AI versus AI. And I gave a talk on this at a different conference at one point about co-evolving AI defensively and adversarially. And then on the offensive side, they have the advantage of just not having to hold the key terrain in order to achieve some impact. They just have to get in a little bit and do something.
Right.
And so that'd be my comments on that.
Right, that makes sense. And Laura, throughout your work, what sort of policies are informing how you conduct the testing and evaluation, and how have they shifted your approach at all, or if at all, I should say?
So I think it's important, those strategies that the federal government puts out, then followed by the policies that evolve from those strategies. Then the manual, and the DoD, we have instructions, manuals, and guidebooks that then support all of that. But across the federal government, having that high-level strategy is so critical for guiding the direction of how we're going to use AI. And just the trickle-down effects of how the policy process works from that strategy, setting that strategic direction, going through the process of writing policy, and then how we're going to implement that drives this whole machine of everyone from industry to us in academia who are doing research. And so I think just foot stomping, I'm a statistician that works in policy, so it's like very confusing to me some days, but how important that impact can be for our federal leaders to say, we're going to use AI, but we're going to use it to solve hard problems, to have mission impact, and we're going to do it in a way that protects the privacy of our citizens, that is safe for our warfighters. That is such an important piece of all of this, because otherwise there's just a lot of one-offs that go on without that overarching guiding strategy. So that being said, I've had the opportunity over the last 6 months to support the DoD in rolling out some of their initial policy, DoD instructions and DoD manuals. So for anyone that works in defense, or anyone else that's interested in how the Department of Defense tried to tackle writing a policy and a manual for how we're going to test AI, the DoD released these in December of 2024. And so they are really guiding the new processes we need for test and evaluation, but also what are those new elements that we need to be considering. So for example, on the DoD side, we have the responsible AI strategy that outlines 5 ethical principles. One that sticks out in my mind as something that drives kind of a different approach is we need to have the ability, we need to have governable AI, which includes the ability to disengage that AI when something unintended comes our way, or we are expecting maybe a not optimum outcome. And so that drives the need to test differently. Well, how do we actually try and trigger that disengage? How do we give it something it's never seen before to make sure it can do that? And then coupling that into the mission, if the AI disengages, does the system disengage? What does the operator do? What warnings do they get? Thinking through that whole pipeline of what does this, one strategy statement that says we have governable AI, it must be able to disengage. How do we take that all the way through a mission thread and make sure that that policy and strategy element doesn't have unintended consequences in itself. So I think that's a really important challenge for us to be thinking about right now as we write these high-level statements of must be fair, must be governable, must be traceable. How does that trickle all the way down into practice, and how do we make sure that we don't come up with our own unintended consequences through the policies that we set for ourselves? The last thing I'll say is, thinking like our adversaries, the US puts a lot out there in public information about what we're doing with AI, what our big picture intents, our roadmaps, our policies. They are all available online, which is a strength for communication within our country. But we also need to think about how our adversaries might take the fact that they know that we are requiring systems to build in disengagement into our systems and use that against us, and then be prepared to counter that as well.
You brought up a lot of great points, giving something AI it's never seen before. That blew my mind. Putting things out into the public. Have you seen, just a quick follow-up, any threats that have come out of having that information so accessible?
No.
Yeah. Not yet.
But we're trying to put on our, I should ask Ian. He thinks like a red teamer. We're trying to put on our best red team hats and say, how could an adversary use this against us?
Yeah, that makes sense, yeah. And Paul, as we talk about AI, how should agencies and organizations approach cloud to provide the necessary infrastructure for this tech?
So I think when you're talking about artificial intelligence, you have to think about two different things: training versus inference. And they have different compute requirements. So training itself isn't just a Boolean start training, end training. You're creating multiple models. You're evaluating them against each other. Some of these larger language models require months of training, and so 100% compute for months at a time. But then all of a sudden, the team stops. And if you are a team that is doing training, then cloud is certainly useful for budgeting and all that. And training is what has been, making the news and the headlines the most over the past 6 months or so. But I think inference is interesting too. So we are at Microsoft building AI into every application. If you've played with Copilot in Office 365, you have a Copilot in Word, a Copilot in Excel, a Copilot in PowerPoint. And if you talk about scaling that up to a larger organization like an agency, then you need to have that ability to scale as users are using the different models. But you also require low latency on those models because they're integrated. If you want to run a large language model to perform spell checking, you want that immediate response. Because you're not going to wait a half an hour for your document to be spell checked. Whereas if you are generating a report, you're content, a 30-page report, you're content with waiting 20 minutes for the large language model to finish because it's going to take you 2 days to read that document. And so being able to have the compute where the users are is an important key going forward.
That makes sense. And I think each of you have brought up at least once how threats are evolving. Oh, yes.
I'll add one other thing. When I just joined Microsoft about 6 months ago. And when I joined, I thought, wow, this is a difficult business. Investing in CapEx during a period of AI burstiness has an opportunity for overinvestment, underinvestment, and just the wrong investment. Because the models are getting larger, taking advantage of new systems as soon as they come out. And if you overinvest in make a promise in a particular generation of GPU, you might be missing out on future opportunities. So it's very difficult, and I wouldn't wish that on any agency or any organization.
Yeah, so as you queued up the next question, well, as we talk about these future opportunities, I think the through line throughout this conversation has been sort of the broader national security impacts of AI, but specifically, like as you look to the future, how do you see AI leading to some of these impacts in the national security space? Cynthia, would you like to start?
My job oftentimes is to talk about things that are really depressing. But this is an area where I actually am really optimistic. That I noted before the ability for AI to really amp up cybersecurity. But what I think it also can amp up is our ability to warn and our ability to share information. I'm really excited about the potential for, as organizations adopt, more automation, more AI into their organizations. And, Paul, I think you said it so well, like we've all been doing it for years, right? Like we've had machine learning and all these things for years, but being able, like, as you're integrating, you're going to have more refined information. And if you share that with us, with the government, like we can help more, right? And Chairman Green said it really well earlier, where he's said, we can't help about a problem if we don't know about it in the first place. And, I think the way I would say that is like, we can't help you unless we hear from others. We can't help others if we don't hear from you. And being able to harness that AI information that we'll be able to get through all of the various technologies out there, like in terms of cybersecurity, and then being able to share that back out is really going to be a game changer for everyone's ability to, for the government's ability to help facilitate network defense, and hopefully for all of your ability to defend your networks.
Mm-hmm. And Ian, how are you seeing some of these impacts of AI in the national security space, and focusing on that future lens?
Yeah, I boil it down to 3 points. One, in the defense world, we tend to operate in a game theoretic environment. So the faster we can react in comparison to whomever we're competing against, the better. So, AI is, especially like things like multimodal AI, which is one of the things we've been exploring, can allow you to take a lot of information of different types, could be images, could be natural language text, synthesize that into something that a human being could interpret. Which could then impact you to a commander, in our case, to be able to decide and react faster. So I think that's one major game player of AI. I've already mentioned the secure by design. I think the symbolic side of the house of AI, because it does come with two traditional roots, a symbolic approach and a historically symbolic approach, which are both rapidly converging now into hybrid methods. But on the symbolic side, secure by design. And then I honestly think robotics is a huge area that's going to be coming up in terms of automating kind of hazardous and or mundane tasks, some of which we've hinted on. And just 2 examples within the Navy. One, you have a co-pilot, we have a watchdog, but it's a similar concept. You might have an autonomous system that is very complex and hard to verify, its performance, upfront, right? And so going back to the operational resilience side of that house, we have a more, COLREGs is the way in which we properly navigate at sea, laws and conventions where you should steer right or should steer left, depending on configurations of ships. And so we've developed a formally verified watchdog that can verify whether an unmanned surface ship is properly executing the laws of navigation at sea. And so that's another approach where your co-pilot can say, hey, this autonomous system might be operating a little squirrely or not in accordance with regulation. So that's an example. That's kind of looking at hybrid methods of symbolic and statistical methods coming together for good effect.
Right, and Laura, from the academic T&E perspective, what are some of the impacts you're seeing as we look to the future?
Yeah, so I like to there's obviously the potential for tremendous impact, but I like the word Paul used, AI bustiness, like it's going to burst. Burstiness.
Yeah.
Oh God. Burstiness. We need to be thinking strategically about how to avoid the AI bubble bursting, and our work at the National Security Institute really focuses primarily in defense and intelligence community kind of lines of effort. And so I've come up with kind of my 3 principles on whether this AI journey that we're on is going to have impact in targeting where we're investing early to make sure that we will have success. And so the first one, no surprise, because I am a statistician by training, is do you have data? And is that data high quality? Do you understand ground truth in that data? And can you maintain that data pipeline? And in a lot of defense applications, that is a very hard thing to say yes to. So making sure that you have data, because what is the AI learning from? It's learning from the data. And while that can be kind of the more dry and boring part, it is absolutely essential for success. The second one that I look for is this going to improve the current state of operations? Or could we be going with symbolic AI or just rules of thumb? Are we going to get mission impact out of deploying AI in this situation? And the last one is, do we have an information overload situation? Because that is the niche where AI is going to help us solve problems. If it's very sparse information, humans are really good at kind of contextualizing and understanding that sparse information. We can bring in physics-based models and other traditional things. Where AI is going to really help us is when we're in that information overload space. And so when working with our partners in the defense and the intelligence community, when I think about those three criteria, the immediate areas where I see a lot of impact are one that Cynthia brought up earlier, the business processes, because we can control our own data collection, we have all our documents, but not just business processes at large, the acquisition processes. How can we improve acquisition efficiency is a big bottleneck right now. And then the other one is on the Department of Defense and on the intelligence side, we're thinking about operating as a joint force. Not thinking, we are. And so that has many information streams from different departments connecting to the Defense Department with the Intelligence Department and engineering that right from the start so that we are building situational awareness. So those are my two big areas for impact that I like to emphasize.
Yes, and Paul, I'll turn it over to you.
Yeah. Ian took my favorite multimodal fusion. It's, the ability to incorporate data points from all different types of modes of collection. I think one of the most interesting things, and kind of both for us and for our adversaries, and one of the most scary things for us, because of our adversaries will have access to it. The idea of agents, I think the next 18 months are going to be extremely fast moving in the area of AI agents. AI agents are essentially a ability to task a large language model to perform some action with a data source and with some guidelines of what you want it to do. And you know, a couple of years back, we were talking about our adversaries using the hosted large language models to do bad things. But if you're a bad guy, you're going to utilize your own models. You're going to create your own models. It's not that hard to do. And those models won't have the guardrails that all the cloud providers are adding. So, so if you are able to create a large language model or leverage an open source model that has no guardrails, provide it some tasking that will provide it the ability to stop at nothing until it completes that task. I mean, that's a pretty dangerous thing. Something like, you know, here's all the information from the internet. Take down the New York Stock Exchange. That is something, you know, an adversary might do with a large language model and an agent framework. However, there's a lot of potential opportunity with the agent frameworks as well for automation of the work that we do every day in the U.S. government. So.
Yeah, it's definitely exciting to learn more, but taking down the New York Stock Exchange, scary, terrifying. There's a lot of change happening very fast, and I appreciate all of your work that you all are doing in it. I look forward to connecting in the future and seeing where this all goes in a very short amount of time. So thank you for joining the discussion today. There we go.
Thank you.
Thanks.